In this video, we're going to be taking a look at the Creality Ender 3 S1. I'm going to walk you guys through the initial setup and assembly of this machine. We're going to look at a very simple upgrade for this printer. We're going to do a bunch of test prints, and at the very end, I'm going to give you guys my honest opinion of this machine after using it for several months now. Big thank you goes out to Mech Solutions, that's mechestore.com, for setting me up with this printer so I could bring this video to you guys. If you're in the market for a Creality printer, go check them out. And if you're in the market for some 3D printer upgrades, check out my store, and that's embracemaking.com. So let's get started. Creality has been in the 3D printer game for a while now, and as you would expect, the Ender 3 S1 comes packaged very well. Inside of the box, you're not really going to find any surprises here. Of course, the box contains the 3D printer itself, along with all of the accessories that you would expect in a modern 3D printer kit. Similar to many other 3D printers on the market today, the Ender 3 S1 comes mostly pre-assembled, but there is some minor assembly to do once you remove everything from the box. The gantry is separated from the base of the machine, and once you get all the parts laid out onto the table, you'll also see that it becomes clear that you will be installing the new Sprite dual gear extruder onto the machine as well. Beyond that, there's only a few other parts that need to be installed, like the LCD screen as well as the spool holder. Step 1 is to take the gantry and place it on top of the base of the printer. There are machine slots to locate the gantry on the top of the printer, and so it's very easy to see where you'll be putting the gantry. Then you can take 4 of the M5x45 socket head cap screws and use those to fasten the gantry to the base of the 3D printer. When you have the machine flipped onto its side, it's pretty obvious where these M5 socket head cap screws go, so you can go ahead and tighten those down. With those bolts tight, you can turn the printer back upright, and the LCD screen holder will be installed next. This bracket installs on the right hand side of the machine using 3 of the M4x18 socket head cap screws. There's also a small rectangular locating feature on the side of the bracket that slips into the side of the machine, so everything stays aligned while you're tightening it down. The LCD screen itself is connected to the printer using the multicolored ribbon cable coming out of the right hand side of the printer. It's a keyed connector, so you really can't screw this up. You just simply plug it in, and then the LCD screen will attach to the printer using the pins on the bottom of the case. Place the pins through those holes and then just slide the whole screen down to lock it into place. During the assembly process, one of the things to watch out for is the adjustment of the V-wheels. If you're new to the 3D printing world, a lot of these hobby grade machines use V-wheels and V-slot aluminum extrusion to create a linear motion system. In the case of the Ender 3 S1, the print bed rides on V-wheels, and they are mounted with and can be adjusted by the eccentric nuts on the right hand side of the machine. When you manually move the print bed back and forth by hand, you should feel like there is no slop or play in that motion, and you should also feel like there are no indentations or flat spots on the wheels. Flat spots would indicate that those wheels are too tight, and a wobbly motion will indicate that the wheels are too loose. You can use the included 10mm wrench to make changes to those eccentric nuts accordingly. Now we can install the Creality Sprite direct drive extruder onto the gantry. It's going to use 4 M3x6 socket head cap screws to secure itself to that X carriage bracket. Conveniently, the extruder is designed such that it sits on the bracket and you don't actually have to hold it while you tighten these screws down. Just remember that these are M3 screws, so you do not have to go overboard with tightening them down. With the print head now installed, we can attach the extruder wire retaining clip in preparation for completing the wiring later on. Looking at the back of the printer, this piece simply clips on to the metal bracket, holding the lead screw nut on this side of the machine. Next, we can grab the spool holder, and it comes pre-assembled with the filament runout detection sensor right on it, and this piece clips onto the extrusion at the top of the machine. The spool holder tube will simply insert into the spool holder bracket, and you just rotate it to lock it into place. And since we're up here anyways, you can now take that small connector at the top of the frame and plug it directly into the filament runout detection sensor, and this is another keyed connector, so you won't be able to insert it backwards. Now before we go any further, this is another step that you won't find in the instruction manual, And I do this to all of my printers that are of this gantry style configuration. I take 2 metal bars of the exact same length and I manually lower the gantry onto those bars to ensure that the left hand side and right hand side of the gantry are at the exact same height. Since these bars are resting on the bottom frame members, that is going to ensure that the gantry is square to the rest of the frame. With the machine powered off, you can manually raise and lower that gantry by twisting the lead screws with your hand at the back of the machine. If the 2 sides are not even, you should make adjustments with the stepper motors disconnected and the synchronization belt at the top disconnected. With that out of the way, we can now move on to the wiring, and at the back corner of the machine, there are several connectors where we can make connections for the Z stepper motor, as well as the filament runout detection sensor, and those connectors are blocked with these nice little dust boots. All you need to do is remove the dust boots and push the connectors into place. The 4-pin is for the stepper motor and the 3-pin is for the filament runout detection sensor. On the other side of the machine, the 4-pin connector coming out of the base of the printer plugs directly into the stepper motor. Up at the top of the extruder, the large flat ribbon cable will plug directly into the receptacle on the extruder. There are locking levers that you can push out of the way, and there is a strain relief clip that will retain the flat ribbon cable. So you have to sort of manipulate that cable to get it into the retaining clip and then lock everything into place with the locking levers. When you're finished, it should look something like this. At the back of the machine, the flat cable can be inserted into the retaining clip that we installed earlier, and conveniently Creality puts a sticker on the cable to show you exactly where. This ensures there's sufficient length on that cable for the full range of motion for the print head. A little further down on that same flat cable, there are 2 more connectors. The 4-pin connector is for the X-axis stepper motor, and that will plug directly into the bottom of the stepper motor. The 3-pin connector is for the X-axis limit switch, and that gets plugged into the limit switch hidden behind this shroud on the left-hand side of the machine. Since it's a bit out of sight, you may have to take a peek under that shroud to see the orientation of the connector. And that covers all of the wiring, but the last electrical consideration is to switch the input voltage on the back of the machine. Use a small tool to push on the switch. I'm in North America, so I'm going to change it over to 115 volts. Now we're almost finished with the assembly, but one of the final things to do here is, just like with the print bed, we're going to be checking the V-wheels on both the extruder and the X gantry. You can try spinning the wheels by hand, and if they're slipping, you'll know that you need to make adjustments to the eccentric nut on the print head. If any adjustments are necessary on the print head, the adjustable nut is on the bottom wheel. Similarly, on the X gantry, you can try and spin those wheels by hand, and you can try and wobble the whole assembly back and forth. And if you're noticing that anything feels loose, then you can make adjustments to the eccentric nuts on the X gantry. On both the left and right hand side of the gantry, the adjustable nuts are on the inside wheels. Just remember that over-tightening V-wheels is not better. When you over-tighten V-wheels, they will wear out prematurely, and you will find that it feels like there is a flat spot in the motion of the component that you're moving back and forth. You have to find the sweet spot where there is no slop or play in the assembly, but it is also not too tight. Another good quality control check here is to ensure that the screws on your Z-axis couplers are tight. If they are loose, it's going to wreak havoc on your Z-axis accuracy during your prints. While we're looking at the Z-axis, you can also inspect the lead screw nuts. Don't be alarmed if at first they appear to be loose. By design, they are intended to move around laterally to ensure that the lead screw remains straight from the bottom coupler to the top tooth pulley. This compensates for pretty loose assembly and manufacturing tolerances. What you don't want to see is any sort of vertical play in that assembly. Vertical play in the lead screw nut assembly will lead to even more backlash in the lead screw nut. One unfortunate observation I did make, though, is that despite all of the additional play that lateral movement allows for the lead screw to remain aligned top to bottom, the lead screw does still come in contact with the metal bracket. Therefore, that lead screw is still being gently bent as the gantry moves up and down. So now we can turn the printer on and we can head over into the control menu where we can head over to temperature, and we're going to be looking at the print bed temperature. I'm going to set the print bed temperature to 60 degrees in preparation for leveling the print bed. The reason I want to preheat the print bed to 60 degrees is that things change shape and size with temperature. Therefore, leveling a hot print bed will be a more accurate representation of the print bed during actual printing conditions. Once the print bed has sat at the 60 degree temperature for a few minutes, we can head into the menu, and what I'm going to do here is I'm going to reset the configuration. In the bottom right hand corner of the screen, you'll see that the Z offset value has been reset to 0. I would prefer to start fresh, and we'll set that value ourselves in a little while. Now I can hit the auto home button, and that is going to home the printer on all 3 axes. The X and Y axes home immediately, and the print head moves to the center of the print bed, deploys the probe, and then sits there awkwardly for a brief moment in time before taking action and homing the Z axis using the probe. I'm not sure what it's waiting for, but it does eventually home. After probing the center of the bed, the print head moves back to a safe Z height distance of 10 millimeters. But since we need to level the print bed and we need to set the new Z offset height, we should move the print head back down to the Z equals 0 position. To do this, go back in the menu and head over to the prepare section where you're going to select move, and then you're going to head over to the Z axis and bring it down from 10 all the way to 0. As you scroll using the knob, the printer live adjusts the axis so you do not have to press the button to instantiate a Z axis move. And now that we're at the Z equals 0 position, as the printer would understand it, we have to now set the Z offset value. So we're going to head again back through the menu, and we're going to select the Z offset option. And then we can adjust that value down into the negative position to get the print head to come closer to the print bed. Grab yourself a piece of regular printer paper, and you want to slip that piece of paper between the nozzle and the print bed. And we're going to be using this to determine the correct printing distance for the nozzle away from the print bed. The goal here is to move the nozzle down using that Z offset value to the point where it comes in contact with that piece of paper. If you've been 3D printing for a long time, you will be well aware of this method, but if this is your first printer and you're new, you're going to want to have a light to medium drag between the nozzle and that piece of paper. What you don't want is the nozzle pinching the paper such that you can't move it, or that it's so close that the piece of paper is torn and ripped. Like most things, practice makes perfect, and as you continue through your 3D printing journey, you'll come to learn the perfect amount of pressure on that piece of paper from the nozzle. Once I'm happy with my offset value, I'm going to head back into the menu, into the prepare section, and I'm going to hit disable steppers. This is going to allow me to move the print head and print bed around manually by hand with the printer still on. I'm going to try and position the nozzle directly above each of the 4 adjustment screws at the 4 corners of the machine. And again, I'm going to be using the piece of paper method here, and I'm going to slip the paper between the nozzle and the print bed, and I'm going to use the adjustment screw to adjust the bed up towards the nozzle. I'm aiming for the exact same amount of pressure between that piece of paper and the nozzle as I did with the center of the print bed. If for some reason you notice that there is a large gap between the nozzle and the print bed, you don't want to make large adjustments at one corner of the machine all at once. From my experience setting up many 3D printers with these 4-point leveling systems, if you make large adjustments at a single corner all at once, you start introducing bending and twisting into the print bed. Instead, what I would recommend doing is making a small adjustment at that corner, and even if you don't have the proper amount of drag between the paper and the nozzle just yet, I would move to the next corner and again make a small adjustment, and then work my way around all of the corners making small adjustments until I get back to the original corner and again make another small adjustment. Hopefully you don't have to go around too many times, but by doing it this way, you are much less likely to introduce bending and warping into the print bed, which will cause larger problems later on. Also keep in mind here, you don't necessarily have to go around from corner to corner in a circular motion. You can move diagonally across the print bed from corner to corner, and sometimes I sort of just mix it up and do it randomly until I'm happy with the distance between the nozzle and the print bed at all 4 corners. Occasionally, I will also double check the position at the center of the print bed with the paper and ensure that I have not moved the entire print bed up too much, such that the center position is now too tight again. Quite honestly, this whole process can be a bit of a pain, but it's not unique to the Creality products. Most printers with these 4-point bed leveling systems require you to do this. When you finally completed the manual bed leveling process across the entire print bed, now you can head back into the main menu and hit level. This is going to initiate the auto bed leveling process with the CR Touch sensor. The machine will take over at this point and automatically probe a bunch of points across the print bed and generate what's known as a auto bed leveling mesh. Essentially, it's measuring the profile of that print bed surface because it won't be perfectly flat, and later on when you go to print, it will use that profile to make adjustments to the nozzle height so that you get the perfect first layer of your print. With the bed leveling complete, we can now load in some filament, and if this is your first machine, I would highly recommend going with some regular PLA filament. I've got this really nice white premium PLA filament from Mech Solutions, and you can find it on mechestore.com. Before loading the filament, I'm going to move the print head up a little bit so that I have some room between the nozzle and print bed to purge some plastic. Then I can head into the temperature menu and preheat the nozzle to something above 200 degrees Celsius, and usually that's sufficient for PLA. Place your spool on the spool holder and use the side cutters to cut the end off of the filament at about a 45-degree angle, feed it through the filament runout detection sensor and down towards the print head. Use your thumb to push down on the tensioning lever while you manually feed filament through the extruder. You'll eventually feel some sort of resistance and plastic will be purged from the nozzle. The printer comes with a full-size SD card that you can insert into the front of the machine, and it does come preloaded with some test prints that you can try out. For my first print, I'm going to be using my own file, and I've sliced this in Prusa Slicer, which is my slicer of choice. In this video, I'm not really going to get into the fine details of all these slicer settings, and the reason for that is that Prusa Slicer has a configuration wizard which comes preloaded with a profile for the Ender 3 S1. Since I have not modified this printer in any way, that profile is actually pretty good right out of the box. Now what you're watching is the very first print that I've performed on this machine, but as I'm editing and making this video for you guys, I've already been printing with this printer for months now. And so I can happily say that even after months of printing, I have not had to make any significant changes to the slicer settings to get great quality prints off of this 3D printer. As the printer is laying down its first layer, you're going to want to try and pay attention to how that first layer is going down. And if you're experienced with 3D printing, you'll know what that first layer looks like when it's too squished or if the nozzle is too far away. The great thing here is that you can actually adjust that Z offset value on the fly. To do that, you want to click on the Tune button, and then within that menu, you can head down to the Z offset and make live adjustments. And you'll notice that as you bring the Z value more negative, the first layer will become more squished. And as you move in the more positive direction, the nozzle will move away from the print bed, making the first layer less squished. My very first print on this machine turned out to be a success, and you can see here that it's a fairly large print, and I believe it took upwards of 7 hours to complete. Removing your prints from the PC coated flex plate can be really difficult. I had a few cases where I actually broke prints removing them from the print bed, and removing small remnants of filament like purge lines can be a real pain. If you're looking for the perfect balance between first layer print adhesion and the ease of print removal, I would look for a PEI coated build plate. It just so happens that I sell them on my website, embracemaking.com, and I have them in various sizes, including all configurations for the Ender 3. Mine are double-sided, so that means one side is smooth and the other side is textured. Both are coated in PEI, so you can flip that plate over, and on the textured side, it will leave an amazing looking textured finish on your prints. By ordering from me, you would be supporting my work and my channel, and I would really appreciate it. Examining the details of this first print proves to be a little difficult in this bright white color, as it tends to lead to overexposure in the video. Therefore, it might be a little difficult for you guys to see, but overall the print was fairly clean. However, there are some artifacts on this print that I'm not entirely happy with. At first, it would appear that there are little extra blobs of filament on the surface of the print, which are known as zits in the 3D printing community. When looking through the slicer settings, I did notice that the seam position was set to nearest instead of aligned, and so I believe those zits are actually the seam in random positions. I also noticed some imperfections in areas where the printer had to perform very steep overhangs, and so I'm going to change the settings in the slicer to ensure the vertical wall thickness as well, and I think that's going to help. And so this is what I mentioned earlier about only having to make a few small tweaks to the slicer settings to get optimal results. Next up, I'm going to print this model of a skull with a removable top, and it has what's known as print-in-place hinges. Print-in-place hinges are a good way of testing the tolerances of your machine, because if they're sloppy, then those hinges will get fused together and they won't work right off of the print bed. The other reason that I selected this model was that it has a lot of fine details and features. I felt like this would be a good way to test out the capabilities of that new direct drive extruder. When this print finished, I also had a bit of a difficult time removing it from the print bed, but luckily there wasn't as much surface area attached to the print bed, so it was slightly easier. As you can see, the hinge to close the top of the skull worked perfectly, and the little clasps on the side only required a little bit of force to break them free and get them moving freely as well. The clasps seem to lock into place and work, and so the accuracy of the printer seems to be fairly reasonable. The fine details on the rest of the print look really nice, and I didn't see any of those zit-like artifacts like I did on that first hand model that I printed. That's likely because I now have the seam settings set to aligned, and so all of those little features will be lined up in one place at one spot on the model and not appear at random through the print. If you notice that when I pulled the print off of the print bed, there were no supports inside of the skull, and therefore all of those overhangs inside of the empty dome printed without supports. This would indicate to me that the part cooling fan is doing its job fairly well, and the printer is capable of performing pretty steep overhangs as well as fair-sized bridges. The next prints were two halves of a Pelican-style rugged snap-fit case. These miniature cases are often used to hold things like spare nozzles, as well as tools from your 3D printer toolkit. The snap-fit clasps are also intended to test the accuracy of the printer, and I'm happy to say that this printer also passed those tests. The tight snap fit also puts a fair amount of stress on the plastic itself and does a good job of testing the layer adhesion of the material. I'm happy to say that the Mech Solutions Premium PLA did not separate or delaminate, and it held up very well to that snap fit. These cases are another item that I offer on my web store, embracemaking.com, and they come fully assembled and fully equipped with the foam inserts ready to store your spare nozzles or tools. After printing with this machine for a little while, one thing that I noticed that started to bother me was the angle that the filament takes from the spool into the filament runout detection sensor. The filament is forced to abruptly change directions to go inside of that filament runout detection sensor. Looking closer at the brass insert inside of the filament runout detection sensor, you can see that the filament is dragging across the one edge. Some of the white filament is actually being ground off, and you can see, if you look close enough, small deposits of it on top of the runout detection sensor. I do have a solution for this, and I did promise the guys over at Mech Solutions that I would not modify this printer while it was in my possession, but this is pretty minor and easily reversible. So the first thing you have to do is remove the existing filament runout detection sensor, and there is just one M3 screw at the back. If you remove this screw, just be aware that there's a very small spacer attached to that screw, and you cannot lose this thing. Next, unplug the 3-pin connector from the runout detection sensor. Now we can start assembling the solution, which is basically a roller guide for the sensor. And this main bracket has a few holes in it. The one in the very tall boss was tapped with an M4 thread, and the two smaller holes on the face of the bracket were tapped for an M3 threads. The guide wheel slips over the boss, and there are no bearings. It should rotate freely. The washer goes on top of that, and a M4x10 socket head cap screw secures the roller wheel into place. Next, the filament runout detection sensor has two M3 flathead screws in the top, and those are going to get removed, and when you remove these, that metal backing plate will come off. Our new 3D printed bracket does have a brass M3 insert in the one hole there on the front, and the runout detection sensor will be attached to the bracket reusing the original hardware. You can see that the 3-pin plug on the sensor is oriented onto the same side as that brass insert. The filament will now be guided by that wheel, and it will enter the sensor in a nice straight line. This should reduce a lot of friction in the filament path. To mount the new assembly, we can reuse the original M3 screw and spacer along with that original swiveling bracket. The M3 screw will get threaded directly into the brass insert on the new assembly, and that will secure the whole piece onto the spool holder again. The spacer should still allow the entire unit to swivel back and forth, and you can reconnect your 3-pin connector. Another nice improvement over the Creality equipment is the smooth spool holder that is designed for the Creality machines. I made a previous video about this modification, and I will put a link to that up in the top right hand corner of the screen right now. This system, in combination with the new filament guide, should reduce most of the friction in the filament path and result in a much more consistent extrusion. In terms of loading the filament and the general operation of the filament sensor and spool holder, nothing has changed. The sensor is still able to swivel, and I've noticed that there are no more pieces of filament ground off at the top of the runout detection sensor. If you guys are looking for the files for the filament guide, please check the video description down below, and I'll put a link to my printables page where you can download them for free. After that, I spent a lot more time with this machine, printing a variety of things, some functional and some just novelty pieces, such as this articulated dragon. According to my social media feed, this is a very popular print right now, and this is actually the first time that I've printed this model. Turns out it's also a very long print, and this is at 0.2 millimeters, so it's not even the finest setting that you could print on, but I thought it was sufficient in terms of quality. I was really happy with how this print turned out. All of the details came out extremely crisp, and the articulated motion worked flawlessly. Hats off to whoever designed this print because it is really cool, and I normally don't like printing novelty items because I don't like wasting plastic, but I may have to print a few more of these things. Just look at how well those details turned out even at 0.2 millimeters around the face, its eyes, nose, and the scales of this dragon. Because of the new Sprite direct drive printhead, I also decided it would be a good idea to test a few prints that had a lot of stops and starts and therefore a lot of retractions. Things like these desk organizers and these slim hard drive holders were perfect candidates for this job. I saw very minimal stringing in these parts, and probably with a little more fine tuning, I could get rid of it altogether if I tried hard enough. And speaking of stringing, I was able to print PETG on this printer successfully. All I had to do was use the generic PETG settings in Prusa Slicer, and it turned out great. However, what you will notice is that I'm printing on the textured side of my PEI build plate. If you plan on printing in PETG with this machine, I would recommend not using the PC coated build plate that comes with the Ender 3 S1. I originally tried printing one of these YouTube play buttons in PETG on the original PC build plate, and I had to break the part to get it off. With the PEI coated plates on the textured side, the prints stick excellent while the plate is hot, and then when it cools down, they come off very easily. So that brings us to the end of the video where I want to share with you guys my thoughts and opinions on the Creality Ender 3 S1. And so I've been using it for months now, and it's been very reliable for me. I've had very few failed prints, and it's just a very general, overall good printer. The Ender 3 lineup has been pretty much a staple of the 3D printing community now for quite some time, so you really can't go wrong. But I think what I need to do here is compare the Ender 3 S1 versus the Ender 3 V2, just to kind of show you guys what kind of upgrades you're getting with the S1 out of the box. Because the Ender 3 lineup has become a little bit muddied and there's just so many options and models now that sometimes it's not clear exactly what the differences are between the two. And so with the Ender 3 S1, right out of the box, you're getting the direct drive extruder, whereas with the V2, that is something that I had to do myself as an upgrade. You're also getting the CR Touch module for the auto bed leveling sensor on the S1. With the V2, you don't get that. And that's not something that I've bothered to do on this particular machine of mine, but maybe in the future. Also with the S1, you're getting a flex plate. Now this is probably the weakest point of this machine because the prints stick too well. Now it's kind of good and bad because I haven't had any prints fail where the prints get knocked off of the print bed. But they stick so well that I've actually broken some prints to get them off of that print bed. So that's something I'd consider changing on the S1, but nonetheless, at least it comes with a flex plate. On the V2, it does not come with a flex plate, and you'll see here, this is the flex plate that I mentioned earlier in the video that I carry on my web store. So I've done that upgrade on the V2. On the S1, you also get slightly cleaner wiring. It's only marginally better than what's on the V2. This has always been a complaint of mine with all of the Ender 3 3D printers in general. They don't put a whole lot of time and effort into the wiring management. It's slightly better, at least on the S1. In addition, you get the filament runout detection sensor, whereas on the V2, you don't get any of that sort of thing. And finally, on the S1, you get the dual Z setup, whereas on the V2, it's a single Z setup, and that's something that I had to upgrade myself. And so when looking at the price of these two machines, the S1 is only marginally more expensive than the V2. And for that little bit of extra money, you're getting a lot of upgrades out of the box. Now, some people prefer to do upgrades themselves, or let's say you don't like the Sprite extruder from Creality and you want to do a different aftermarket extruder. That is obviously something that you can do, and you can choose the V2 and upgrade it to your heart's content. But it's gonna cost you obviously a lot more money as well as your time. This thing out of the box just works great as is. So I would say that as an out of the box printer, it's a very good choice to get started with. And so that's what I think, at least. If you guys have an Ender 3 S1 or a V2, let me know what you guys think in the comment section down below. The upgrade for this machine that I did with the filament runout detection sensor guide can be found in the video description down below, so go check that out. Be sure to check out mechestore.com and check out my website, embracemaking.com, for more content, more videos, more upgrades, and I hope to see you guys in another video.